Okay, so this is going to be a little quick one. Somebody was saying in the comments that they've been microdosing drawbox exercises for a few weeks and they're still completely oblivious as how form intersections work with objects tilted in different directions. They're looking for some pointers on that. So I got this great program called Magica CSG. This is the beta version that's made by F Tracy. They have a Patreon. I've gotten the beta version by subscribing to their Patreon. And so this is a 3D modeling program which works with SDF modeling, I think. It's called sine distance field modeling. It's something that does modeling with Booleans as opposed to surface modeling. And so I figured this is a really, really good program for demonstrating the problem at hand, which is actually these form intersections. So first, let me go and recenter my camera. All right, so we'll start with the most basic of basic form intersections, which would be a cylinder going into a flat surface. And so I got this thing set up, and I'm going to make that nice and wide so we can have a nice wide surface to look at. So we'll start with low levels of confusion, which means I'm not going to be twisting things out yet. So in this case, if we look at this intersection straight on, orthographic mode, no perspective yet, right? When we start applying perspective, things start to get really weird. We get a circle. And if I turn on the renderer, we can see how as I tilt this, right, that circle simply gets squished. And if I rotate this, right, that circle stays the same, right? Even in this mode, we can see that intersection does not change. It just gets taller. We simply see like a vertical scaling occurring to it. Really, really nice and simple. Okay, so let's turn on perspective. And again, we're not really seeing a whole lot of difference as I rotate around this, right? That's the thing, is it's going in perpendicularly, low levels of there's no extra added levels of confusion. All right, let's slant this thing a little bit. So if I doink, 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 okay. So actually, before I even do that, let's just align everything like so. And I'm just going to start twisting it on this horizontal axis, and we can see that the ellipse is it's simply like elongating. It's simply elongating in the direction. It's almost like you've got this plane, like a slice plane here, and we're twisting it along this slice plane, and we can see that it's simply elongating in the direction of the slice plane. Maybe I should like change the material of this one to like, oh, there. Now we can really see. Here, let's brighten that up. Now we can really see that that intersection clearly. Much better. Right. So as I shift this, we can really see. Oh, it's not long enough, but you can see how it chops off because there's that planar cut right there. This is like the ideal program for demonstrating how this works. Okay, so yeah, let's twist it. And now let's here, how do I center on this object? Oh, good, that centers on it, right? And so now as I turn this, right, we can see how that ellipse is changing, right? So in this case, if I were to turn this again, it's very hard to control it at this angle. Oh, it's extremely hard to control it at this angle. But there, we can see that it's simply vertically stretching. And so we either get a vertical stretch or a horizontal stretch, but what happens in between? Right? That's the real question. So once again, I'm just going to start, we'll just keep turning this thing just to kind of help understand what's going on. Like, if I completely turn it all the way across, oh, look. It stretches out off to infinity, and it stretches in a manner that is parallel to the axis of the cylinder. So what I mean by this is that if we switch it back to orthographic, right, the cylinder has parallel lines that make it, right, that go up and down along the axis. And in fact, it will turn into a rectangle. Well, it'll turn into an infinite rectangle if we really stretch this bar out. And we can even see how that's carving a nice little channel out there. And it's got that, it's got that there. It's got that circular intersection. Right, so that's what's happening is this ellipse is morphing and turning into a rectangle as it stretches infinitely in that direction. Okay, I'll turn perspective back on because this cylinder is zooming off to like a vanishing point somewhere way up there. In fact, here, let's take the field of view and go right, and we can see that it's pointing off into infinity, off into there. There's a vanishing point somewhere there. In fact, maybe it would help if let's just rotate. Maybe I can rotate our view just a little bit. We'll just make that line up there. Right? We can really see how that all lines up now. And we'll just give this all a pan around. So hopefully that helps explain. Okay, so let's turn it like this, and let's take that big box again, make it bright white. Maybe I'll make it slightly semi-transparent as well, just so we can kind of see a little bit of the background coming through. Whoops, not that one. Not that one, not that one. Here, this one. Ugh, I just want to see a little bit of our background. Right. Just so we can see how that ellipse is being stretched out. Like that. So this is, again, it's a basic. It's a. Oops. Oh yeah, here we go. Right. So we're talking about the different angles. I didn't mean to actually rotate that box. Let's put that back. Okay. Probably the reason why it's showing up as black is I have to adjust the settings. There's like no, not that setting. Okay, that was at 2 before. No, that was 4. How about scatter? No. I was thinking that it would, oh, right. It's punching a hole through the box. That's why it appears black inside. Okay. That explains it. Right. All right. So let's turn that cylinder back upright so I can just reset its transformation. Okay. So cylinders are the easiest to understand just because they're circular. Let's change that into a different shape. Like say, let's try rectangle. It's time for some rectangle on rectangle action. All right. So once again, this is a perpendicular intersection. We can widen it as well. That helps us understand what's going on here. And let's just center up on that. So again, you've got a vanishing point that goes up off there. There's another vanishing point that goes that way. We can really clearly see these vanishing points. But as we rotate it, right, then this gets its own vanishing point way up there. So you need to understand kind of what's the alignment of that, right? We can see, there we go. Right. Okay. Let's reset that rotation again. Okay, so we're going to start tilting this. And you can see, oh, look, it's just getting wider now. Actually, here, let me shrink that down a bit. Okay, we'll tilt it again. Same deal, just like the ellipse. However, you can see, oh, right, there's this perspective stuff going on here. We've got a vanishing point forming. This was not visible when we had the cylinder. And if I start swapping this between a cylinder, right, and the box, now you can kind of see, boink, boink, boink. Right, so that ellipse is inscribed in that shape. It's in there. Right, same deal. We're going to stretch this out here. Whoops. Just want to stretch it on that axis. The same deal. I'm going to just turn it into that. So if you're trying to figure out how your ellipse is going to be stretched, your ellipse does follow perspective. It needs to be inscribed within this box shape. And so you need to know, since the box consists of parallel lines, the parallel lines always meet off somewhere at some vanishing point, right? So if you know where those vanishing points are, and it's actually a pair of parallel lines, so there's going to be a vanishing point way up there and another way over there. And then if we turn it back into a cylinder, right, you can see, so this cylinder this circle or this ellipse gets stretched according to that perspective. And if you ever want to know where the middle of that ellipse is, like where the middle of this is, you can draw like an X across the diagonals. That tells you where the center of this rectangle will be. Okay, so let's take that and rotate. Let's spin this. Okay, so this is pretty much just like when we spun the ellipse around. All right, and then, okay, let's put that back. Now's where things get a little bit confusing. So I'm going to take this. I'm going to perform an axial rotation. So we're just going to turn it on its axis. And you're going to be like, oh my God, what's happening? Why is it doing all this, weird shape? How do I figure that out? Like, oh my goodness, that is so. This one is like, extra difficulty. Why? How is it? How is it doing this? How do we? Well, if I spin this fast enough, you might notice that these things are forming a path. If we take this and turn it back into a cylinder, when we start spinning this, oh, hang on. Did I? Right, I stretched it by accident. Okay, hang on. Let's put that thing back the way it was. I think, okay. All right, good. All right, so if I spin this thing on this axis, right, nothing changes, right? Nothing changes. Okay, let's turn it into a square, got a square cross section, and we turn it. Okay, so these points are all traveling around to create an ellipse. They're traveling around to create an ellipse, kind of like this one, except it's probably, it's wider in its cross section. It's here. Can I? Okay, hang on. Let's make one of those. Let's just copy that, paste that in, turn it back into a rectangle. Let's change the color of it to like maybe a red, and then just shrink it down until it fits inside. Okay. I'll swap the material maybe. Okay, hang on. Let's see. I've got to find just the right materials to make this work. Okay, it is a B type. How about if I set it to change the material type? No, I'm trying to make it so that we can actually see. I want to actually see the object inside. Okay, wait, no, I got this. We'll set this one to subtract. Okay, so that one punches a hole, and this one is additive, and then this one I'll set it to a B type. Perfect. Okay, there we are. And now we can see that as I spin this, right, we can see that it's perfectly fitting into this ellipse. Oh, that's crazy, right? We zoom out here, we can even see how it's cut the hole, and we can see how it fits now. And then we can also see that the ellipse makes this sort of projection up here. The other one, is being projected and stretched along that axis. Okay, no, stop. Cool. So let's try some other shapes. let's see. Okay. How about here? I'll turn off the whole cut. So now we can really see that. Let's try something more complex, like a hexagon. And let's just widen that up a bit. Same deal. And actually, you know what? Let's turn that whole cut back on, right? So we can even see, look at that. That's like, just shrinking that down a little bit so you can understand. Okay, we got ourselves a hexagon. Can I do like a star? Okay, right. It's like, I can do a star shape. Okay, now I'm going to turn off that cut through and we can see how does this all behave. This is a much faster update. Whoops, I didn't mean to do that. Here we are. Let's change this one back into the transparent type. Oh, nice. Now we can really see. Hopefully, like it's just easier for me to show something like this to you because it's a faster, just faster for me to indicate like that, and then maybe that'll help you, kind of understand what you're seeing. Okay, I don't know what else. It's like I don't know how many other factors I could use to make this harder. But yeah, it's like so that means you've always got like two surfaces, right? And then you got to question, like, is that surface going in perpendicularly? If it's going in perpendicularly, then it becomes easier to understand because it's just straight on. So whenever it goes kind of across like this, it gets stretched out in one of these axes. It gets stretched out in kind of, like you can see how this pillar is pointing off in a direction. So that direction, that pointing direction, is the direction of the stretch that's occurring. And then, yeah. And sure, I guess I can try things get more and more complex if I do something like we'll take one of these and then we'll duplicate it, move that up, turn it kind of weirdly, right? And then, okay, now this is where we start to get some overload. Okay, right? It obviously gets much harder to understand the more convolution we add, but well, at least you can see it's like, oh, at least those lines, stretch. We can see how that. Make that one white instead. Right. And then let's try and confuse this. Oops. Yeah, even if I turn this thing, right? If I turn it, you just have to think of it in terms of punching through with the cylinder, right? That's the one thing that doesn't change. And then whatever edges show up, they're going to be aligned somewhere on that elliptical edge. Okay, now up here I can see this is kind of confusing, but there we go. Okay. So anyway, I wanted to keep this one short. It's already 20 minutes. Okay, I'm gonna stop. Bye, guys.